X is a random variable having finite variance then for any epsilon greater than 0, probability of this is known as Chebyshev inequality. Probability of mod x minus n greater than equal to epsilon less than equal to sigma square. Sigma is the standard deviation by epsilon square. So that means I will explain the geometrical or physical significance of this, where m and sigma denote the mean and standard deviation of x. So this inequality means actually, suppose this is an interval. This is n minus epsilon and n plus epsilon. So x minus n greater than equal to epsilon means this part, these two parts. That means probability mass outside this interval is less than equal to this. So Chebyshevs actually give you the limits, lower limit and upper limit of your probability mass. So I will prove this inequality for discrete and continuous case. So please write the theorem inequality. So first I will prove for discrete case. What is the discrete case? Let x be a discrete random variable whose spectrum is xi plus minus 1 plus minus 2 etc., where right, and probability of x equal to xi if I equal to 0 plus minus 1 plus minus 2 etc. So this is your discrete distribution. Now equal to, you can write summation xi minus m greater than equal to epsilon if I. For discrete case you can write this because you are considering those xi, their modulus is, that means outside the range of m minus epsilon and n plus epsilon. So you are writing this. Now this is less than equal to summation Because why you are writing this? This is greater than 1. Why? Because xi minus m greater or equal to epsilon, that implies xi minus m whole square by epsilon square greater or equal to 1. Because you have mod xi minus m greater or equal to epsilon, তাহলে ডিসক্রিট রিয়েল ভেরিয়েবল xi minus m greater or equal to epsilon, তাহলে xi minus m whole square greater or equal to epsilon square, তার মানে xi minus m whole square by epsilon square greater or equal to 1. So you can write this. So because of this, okay, our fi to always positive, তাহলে এটা লেখা যাবে, ক্লিয়ার? For all I now summation epsilon square into fi, this one, less than equal to 1 by epsilon square summation okay, I am taking this from whole. Let me write first. Why? This must be, actually total range is minus infinity to infinity, and you are considering only m minus epsilon to n plus epsilon. তাহলে this must be less than equal to this. যদি টোটাল মাসটা নিয়ে অনেক বেশি, ওটা তখন এর থেকে বেশি হবে। So what is this? This is nothing but your sigma square. What is this? This is the expression for variance. দেখো variance এর expression, xi minus m, dispersion না, measures of dispersion, কতটা মিন মাইনাস করলে কি হয়, ডেটা গুলো থেকে মিনটা কতটা ডেভিয়েট হয়েছে, তাহলে this is the nothing but your expression for variance. So that is equal to sigma square by epsilon square. Clear? তাহলে in the discrete case you have proved this less than equal to sigma square by epsilon square. Clear? Now I will prove for continuous case. There will be integration. So in the continuous case, case 2, let x be a continuous random variable with PDF fx, then probability of greater equal to epsilon equal to clear? Same logic. This x minus m whole square greater equal to epsilon square, তাহলে x minus m whole square by epsilon square is greater equal to 1, and fx is always positive or 0, তাহলে this must be greater equal to this. Now x minus m whole square by epsilon square fx dx, that must be less than equal to epsilon square okay. So hence same process, just you have an integration sign instead of the summation. So probability of x minus n greater or equal to epsilon less than equal to sigma square by epsilon square for discrete and continuous. Other forms, okay. Now I will write one remark of that. Shubishev's inequality brings out the significance of the variance as a measures of dispersion, about the mean somewhat quantitatively. You are quantifying the measurement sigma square by epsilon square. তখন আমি একটা অ্যাকচুয়াল ভ্যালু পাবো যদি সিগমার ভ্যালু জানি আর এপসিলনের ভ্যালু জানি। So you have a quantity, okay? And it states that you can write. It states that the amount of probability mass outside the interval m minus epsilon and m plus epsilon is less than or equal to sigma square over epsilon square, which is obviously small for a small epsilon. If the variance is small. That means maximum part of the probability mass lies in this interval. এর বাইরে যেটা very small amount আছে, তার maximum concentration of probability mass is here. and these two portions very less amount, and that amount is given by sigma square by epsilon square. Sigma যদি ছোট হয়, epsilon যদি ছোট হয়, so that will be small. So it gives you, this is the significance, very important significance of Chebyshev's, quantifying the result, and also it gives out that the mass is very less outside this range, m minus epsilon and m plus epsilon. Okay. Now I will explain, this is Chebyshev's inequality. Now I will explain Chebyshev's theorem. Somewhere it is written T also, no problem. I am writing C. Kono boite T, kono boite TSC, so different spelling. Let x1, x2, xn, etc. be a sequence of random variables such that the mean, close the window, and standard deviation sigma exists for all n if sigma tends to 0 as n tends to infinity, then xn minus mn tends to 0 in p as n goes to infinity. This is your Chebyshev's theorem. Sigma n tends to 0. Sigma n of xn exists for all n. So first of all, you have a sequence of random variables x1, x2, xn, etc. It's a sequence, and the mean mn and standard deviation sigma n exists for xn. That means m1 is the mean of x1, sigma 1 is the standard deviation of x1, so on. So mn and sigma n exist for xn, and if sigma n tends to 0, that means sigma n is very small if you n goes to infinity, when as n is large and sigma n tends to 0, then xn minus mn tends to 0, this difference will go to 0. In p means in probability. The notation is in probability, because sequence can be real sequence, real number sequence. That is not, the meaning is that means this xn is the random variable. So in probability, in p means in probability, as n tends to 0. So we are going to prove this. Okay. So your first line of the proof will be this. Let x1, x2, xn be a sequence of random variables such that the mean mn and standard deviation sigma n of xn exists for all n. So first line of the theorem statement is the proof. First line. So now let limit n goes to infinity, sigma n is 0. I am supposing this fact. If sigma n tends to 0, as n tends to 0, so limit n goes to infinity, sigma n is 0. So I am supposing this. So now for any epsilon greater than 0, what is the Cheboshev's inequality? Probability of, tell me, probability of mod x minus m greater or equal to epsilon sigma square by epsilon square. Okay? Now I am talking about xn, so xn mn sigma n. Okay? So this will hold for all. So that is why I am writing xn. So therefore probability is always greater or equal to 0. Okay, I am taking limit can we write this? Taking limits on both the sides and probability is always more than 0. Correct? This will be 0 according to this, because you are assuming that limit n goes to infinity, sigma n is 0. So you are assuming this fact. So you are getting this is a 0. Whatever be your epsilon. Always epsilon is positive. Now what is your conclusion? Therefore okay, clear? Hence or xn minus mn that is a very simple proof using Cheboshev's inequality. That means this tends to 0 in probability. Clear? This is your Cheboshev's theorem. And agetta inequality. So there is a difference between inequality and theorem. Be careful in the examination. Next is, I will use this kind of technique to prove some theorems. Bernoulli's theorem. If xn is a binomial NP variant, then xn by n tends to p in p as n tends to infinity. Now there are two notations, these two are different actually. A beta is the parameter of the binomial distribution and this p is denotes in p, in probability. They are not the same. So let us prove this. This is your Bernoulli's theorem. Since Xn is a binomial NP variate. What is your expectation of Xn? NP. What is your variance? Sigma, standard deviation, root over Q, right? Where Q is 1 minus P, correct? Now for what is your expectation of Xn by N? P. Because this is constant, this is fixed. So, clear? And what is your sigma of Xn by N?
Root PQ by N.
Huh? Root over? Okay? Therefore, limit n tends to infinity. Okay, let me show you at the top. Okay. Limit n goes to infinity, sigma xn by n. What is the value? Bolo, show up. What is the value of this limit? 0. Obviously 0. So, hence by, you can apply now Shubishev's theorem because sigma n tends to 0. Hence by theorem we have xn by n minus p tends to 0 in p as n goes to infinity. That is, xn by n tends to p. That proves the theorem. Shubishev's theorem, if sigma n tends to 0 as n tends to infinity, then xn minus m, your mean is p now. Xn minus m tends to 0 in p. এখানে হচ্ছে xn by n. So that is xn by n tends to p in p as n tends to infinity. নাহলে তো এটা 0 তে যাবে না. Clear? Law of large numbers. Law of large numbers. x1, x2, xn be a sequence of random variables such that Sn equal to has a finite mean Mn and standard deviation sigma n, capital sigma, for all n, if sigma n is order of n. What is the meaning of order of n? That means sigma n tends to 0 as n tends to infinity. That is the meaning of order of n. Order of n মানে কি? As n tends to infinity, sigma n tends to 0. Then Sn minus Mn by n tends to 0 in P as n goes to P. This is law of large numbers. This is law of large numbers. So let us find, so let's prove. It's very easy to prove, because unit Chebyshev inequality theorem, সবকটাতেই Chebyshev theorem, you are applying Chebyshev theorem for that. So first expectation, find out the expectation. What is the expectation? What is the expectation? What is the expectation? বলো প্রদীপ্তা, কি এনিথিং?
না স্যার, সে 0 হবে।
হ্যাঁ, কারেক্ট। আচ্ছা, এক্সপেকটেশন অফ এস, আচ্ছা লেট মি সেপারেট দিস। তাহলে এটাকে সেপারেট করলে 1 বাই n এক্সপেকটেশন অফ এস n মাইনাস m n তো ফিক্সড। So let me calculate expectation of S n. Your S n is this one.
স্যার মিন তো ইভেন বলে দিয়েছে।
Has a finite mean Mn. Okay, that is the mean. Okay. See. And what is the standard deviation? That means you have to calculate sigma of Sn minus Mn by n. বলো। What is the standard deviation? So standard deviation of this part is 0. Only this part. So 1 by n sigma Sn. What is your sigma Sn?
ক্যাপিটাল সিগমা।
Sigma n by n. Sigma n. Okay, I am writing here. So sigma of Sn minus Mn by n is sigma n by n. Clear? Now take limit what is the result? Shubhadeep? 0. ওকে, তাহলে বাই so by Chebyshev's theorem, Sn minus Mn by n tends to, what is the mean? Mean is 0, right? So that was the theorem. Okay, note, let M1 into Mn be respectively denote the means of x1, x2, xn, then correct? Okay, tell me, is it clear? M1, M2, Mn, etc. be respectively denote the means of x1, x2, xn. Then Mn is expectation of Sn. And what is your Sn? Sn is the sum of this n random variables x1, x2, xn. And expectation of x1 is m1, expectation of x2 is m2, etc. Expectation of xn is mn. And we write x bar. What is your x bar? Mean of this n random variables x1, x2, xn by n. That's a notation. That is equal to Sn by n. So x bar is Sn by n. What is your m bar? Small m bar, m1 plus m2 mn by n, and that is equal to mn by n. That's a notation. Okay, Pradeep? Hence, law of large number, LLN. So I'm writing LLN, law of large numbers, the previous theorem, may be written in the form x bar minus m bar tends to 0 as n tends to infinity. Well, tell me, go to the theorem, law of large number, and just replace your Sn by n by x bar and mn by m bar. That your law of large number can be in this form. This is also very important. Law of large number straightforward যদি হতে না থাকে তাহলে এই ফর্মে লিখতে হবে। বুঝা গেছে? ওকে? Now I will prove law of large number for equal components. So I am writing law of large numbers for equal components. If the random variable variables x1, x2, xn all have the same mean, same distribution with existent mean m and standard deviation sigma, and x1, x2, xn are mutually independent for all n, then x bar tends to m in P as n goes to infinity. What is your x bar? X bar is x1 plus x2 plus xn by n. So this is your law of large numbers for equal components. If the random variables x1, x2, xn all have the same distribution with existing mean m, all have the same distribution with mean m and standard deviation sigma, and x1, x2, xn are mutually independent for all n. These two are very important. All have the same distribution and mutually independent. So this is the case for law of large number for equal components. So let's prove this result also. Written the theorem. So you have to start with this, that x1, x2, xn are n independent random variables all having the same distribution. So let the random variables x1, x2, xn all have the same distribution with existing mean m and standard deviation sigma. Xn be mutually independent for all n, then mean mn of xn is given by what is your Mn? Tell me, what is your Mn? তাহলে m, how many times? Nm. Clear? Standard deviation sigma n of Sn is given by sigma n equal to sigma of right root n sigma. তাহলে therefore limit n goes to infinity sigma n by n কত হবে? What is the result? It will be 0. তাই তো sigma by root n, so root n tends to infinity, that will be 0 only. তাহলে now hence the law of large numbers holds. Therefore x bar minus m bar as n tends to infinity, where x bar is x1 plus x2 plus xn by n, লিখে দেবে, that is x bar tends to m bar as n goes to infinity. Yeah, that's the final result. Let's have a problem on Chebyshev inequality. Let's have a problem. One problem I will solve. Clear? So law of large numbers and law of large number for the case of equal components. Chebyshev's inequality and Chebyshev's theorem and Bernoulli's theorem, binomial theorem. So show by using this inequality that in 2000 throws with a coin, the probability that the number of heads lie between 900 and 1100 is at least 90 by 20. That is the question. Very interesting question. So let x be the random variable. So if you want to use the inequality, what is the inequality? Let me recap. Probability of mod x minus m greater equal to epsilon less than equal to sigma square by epsilon square. Okay? আরেকটা ফর্ম আছে. So you can write probability of mod x minus m less than epsilon greater equal to 1 minus greater than 1 minus sigma square by epsilon square. Complementary part. This is the complementary part. So let x be the random variable denoting the number of times the head appears, because you are talking about number of heads. So let x be the random variable denoting the number of heads appear. Okay? So what is your expectation? What is your expectation of x? Pranati bolo, what is your expectation of x? Binomial bolo, Shreya? What is your expectation of x? Bolo. NP, n is 2000 and probability of success is always half. Clear? What is variance? Variance x. Variance of x. Follow. NPQ. তাহলে 500. Clear? So in any case of using this inequality, you have to find out the mean and variance. Without that you cannot. Okay? So let me write. I hope that you have written the question. So by Chebyshev's inequality, probability of okay, so let me calculate. Okay, you have to find out probability of 900 less than equal to x less than equal to what is given? 1100. What is your m? 1000. Probability of minus 100 less than equal to x minus 1000 less than equal to 100. Right? What is your sigma? This is your this is written as and probability of mod x minus 1000 less than epsilon 100. Then you can calculate your sigma is already calculated 500 and epsilon is 100 তার মানে তাহলে this is equal to 1 minus না এই যে this one you can use this identity complementary part এটা করলে you will get 19/20. Is this clear? এটা ক্লিয়ার? এখানে কি আছে? কিন্তু ইনইকুয়ালিটিতে কি আছে? greater equal to. This is the complementary part. তাহলে কি ইউজ করবে? 1 minus sigma square by epsilon square. এটা কমপ্লিমেন্টারি পার্ট তো। ও আচ্ছা ওটা কত না এখানে কোশ্চেনের জন্য। মানে other forms of inequality, other forms of Chebyshev's inequality. বুঝতে পেরেছো? এগুলো হচ্ছে আদার ফর্মস, ওগুলো ইউজ হতে পারে। Okay, this is our first lecture for today.